Hello, hope everyone is doing very well. We're gonna do some more problem regarding double integrals. Remember, double integrals, you are taking your region, which is your x and a y, and you divided your region into infinitely many rectangles, and you find the area of one representative, and you're going to call that one right here is your dx, and that's your dy, and you said the area of one representative is delta x times delta y. Then what you're gonna do, you're gonna say, I'm gonna sum up all the x's and I'm gonna sum up all the y. And when I say sum up the changes in x and y. Then in order, for example, if this is a region right here, and your region represented by some function of x, you either have to make your y fixed or make your x fixed. You go from a to b, but in here, if it's respect to x, you have to write the bottom function, which maybe is g of x. That's the lower function or the bottom function. And this one is your top function or upper function. And if this coefficient is 1, that represents the area of a region. If this coefficient is 2, you double the area. Triple it, you triple your area. Therefore, if this is a constant multiples, you can move your constant multiples outside, find the area and triple it. What happens if this one is not a constant multiples and that represented function of x and a y? Then this one is sitting for a third variable. Maybe the third variable is a z, which x and y are independent, and z is dependent on these two of dy dx. This one a to b, and this one is going to become the lower one, and this one with the upper one. This is nothing except base area times the height, and that's the volume. Therefore, you can either do the area or you can do the volume. But what is important is these two, the lower limits and the upper limits. This lower limit, upper limits must be area of a region. Let's do some example. If I have from 0 to 1, and in here I have 0 to x, I don't care what is in here. That, because you have a double integral, I need two variables of integration. Because the inside is a function of x, the outside has to be dx. The inside, you could call it a dy. You can call it a dz. It depends how you represent the function. You can say f of x equal to z or equal to x, or most of the time we use y as a function of x. Therefore, I'm going to call this one the ordinary variable we use, dy, 0 to x. But what am I going to put right here? I'm going to put right here 1 minus x squared. Okay, let's talk about this. If this represented a density, Density times area is a mass. If this is your Z, and that's the base area, that could become a volume of a surface. That has many applications in physics, in chemistry, in sciences. Therefore, what we learn here, how to solve double integrals. Then in the future courses, your instructor tell you what this quantity means. Therefore, I don't know what the name of that is. But because the outside is constant, that has to give me some kind of a scalar quantity. That scalar quantity, if it's a volume, is unit cube. It cannot be area because you already, this is anything other than 1. Okay, let's solve this. First, you have to determine the region. The region said outside is x. This is x equal to 0. X equal to 0 is the y-axis. This is x equal to 1. X equal to 1 is right here. This is y equal to 0. Y equal to 0 is right here. This is y equal to x. Y equal to x is here. Therefore, I know I'm talking about that region. Right now, you have to make a decision. Do I want to do vertically simple? When I said vertically simple, you want to make your x fixed, which is already is. Do you want to make your y fixed? What is the point of intersection right here? X is 1, and x equal to 1, y is 1. Your y is also from 0 to 1. But if this represented y equal to x, because you made your y fixed, the x must vary. And x is your y. And here you have to understand, these are your x. X is a distance from the y. This is your right function. This is your left function. Your right function is the upper limit. Upper limit for x is 1. Your left is y. Do you see how this one is a function of the outside variable? And this one is going to become 1 minus x squared. I did change the order. And both of them should give you exactly same answers. The person invented this was Fubini. And this is called Fubini theorem. Means by having dx dy, that's exactly equal to dy dx by changing the limit of the integration. But what is the difference between these two in doing the double integral? This is impossible to do. Because if I want to do u substitution, if this is u, I need a du. My du is negative 2x. I don't have a negative 2x here. Somebody said, I'm going to do trig substitution. Yes, you might be able to do trig substitution. Then you're going to change that dx to d alpha. Then you have to solve the inside in terms of a trig substitution. But what you going to do with that y? Then that y should become r sine of theta. And you're going to end up with some difficulty doing that problem. While in this one, respect to y, this is constant. You don't even need that. Then when you do this one respect to y, which 1 dy is integral is y, and y go from 0 to x, you give birth to an x, and you can do u substitution here. Therefore, do you see when you change order, sometime you get yourself in trouble? Means you make the double integral impossible to do or hard to do. Therefore, in this one, because this is function of x, and x is the outside integral, I'm just going to move it outside, because this is nothing when you do with respect to y, call it constant multiples. And I'm going to do this one from 0. And because this is a function of y, this is my x. And I'm going to do dy. When I finish this, then I'm going to come back and do the outside respect to x. Then this is y from 0 to x. This is y, x minus 0, x. Then the answer to that one is x. Therefore, that problem becomes 0 to 1, x square root of 1 minus x squared dx. And this problem is very easy to do using u substitution, which is 1 minus x squared. Du is negative 2x dx. And that's very easy. I do have an x, but I don't have a negative 2. I can multiply this by negative 2 and divide the outside by negative 2. Then I have a negative 1/2 integral of square root of u du, because your du is 2x dx. Then what is u to the power? Please don't put 0 and 1 in here. 0 and 1 belong to x. You either have to change the limit of integration. When x is 0, u is 1. And when x is 1, u is a 0. Then you have to switch, because this should be upper limit. You make it 0 to 1 and change the sign. Then you can do u substitution. And u to the power of 1/2 become u to the power of 3/2 times 2/3. And don't forget, I have a 1/2 here from 0 to 1. And that's become 1 to the power of 3/2 is 1. And the answer is 1/3. I don't know if that 1/3 represented the volume. Then I'll call it a u cube. Therefore, this one is